So the 2-1 takeaway, we're going to start looking at some patterns and come up with a conjecture for these patterns. Conjecture is a fancy word for finding a pattern, finding a rule for that pattern. So here's the example I like to use. Let's say you're watching a basketball game and you notice, like, okay, all the tall people, like anyone who's over 6'6", they tend to be good. Like that tall person's good, that tall person's good, that tall person's good. So in your head, you start to make conjecture, right? You're like, man, all you have to do is be tall. If you're tall, you're automatically good at basketball. That's all it takes. Okay? That would be a conjecture, right? It's unproven, it's anecdotal, but that's something that sometimes people say, right? If you're tall, that's all it takes. You're good at basketball. But we realize that conjecture maybe isn't the best rule. Why? Why? When I say it, you have to be tall to be good at basketball, what do you think? No, right? And then you think, well, no. Why? Do you think of short people who are good at basketball? Do you think of tall people who are bad at basketball? There are tall people who are bad at basketball, right? So that's what we would call a counterexample. So an example that goes against our conjecture. So that's something, that conjecture is something you formulate in your head, but you realize after looking at some examples or thinking of some examples that that's not a good rule to have, right? You can be short and be a real good shooter, be good at basketball. You can be tall, but be gangly, can't move, and have zero hand-eye coordination. All right. So that's a bad conjecture because of so many counter examples. We're going to take that same sort of thought and use it with math. Okay. So we're going to try to find the sum of the first 30 even numbers. And then we're going to make a conjecture, make a rule about the sum of the first even numbers. So to do this, 30 seems like a lot, right? So we're not going to just count like 2 plus 4 plus 6 plus 8 plus 10 and then keep track of how many we have. We're going to make a rule for it. So let's first think about, well, what would the sum be for the first even number? What would the sum be for the first even number? Yeah, the first even number, what is it?
2.
It's 2. The sum of the first 2 even numbers.
6.
Be 6, right? It'd be 2 plus 4, which would give you 6. So we have this chart here. We're going to put the terms. What we're trying to relate the terms, because eventually we want to get to 30 without having to write all this out. So we're going to relate the terms. There's something that we do from the terms to get right to the sum, right? Without having to do the work in between, okay? Because there's a rule, there's a formula. So let's do the first 3. Usually we have to list some out before we find the rule. The first 3 would be 2 plus 4 plus 6. That would give me 12. Anybody see a rule or a pattern yet? Usually takes at least 3. What would the next one be? So 8, right? 2, 4, 6, 8. So it's basically this, right? And we just add 8 to it. Which would make the next one the 5th one. The sum of the first 5 terms would be 30. Yeah, I just add 10. Do we see anything yet? Again, we're trying to relate these terms. So how did I get from 1 to 2? How did I get from 2 to 6? How did I get 3 to 4? Or 3 to 12? 4 to 20? 5 to 30? So how can I get from 6 to this number without having to do all this work in between? Yes?
Or do you add, like the multiplication of the number, like 5 plus 5, 6 plus 6 is 12, 4 plus 4 is 8.
Ooh, that's close. Oh man, that's awesome. So the problem with that would be, so what would the sum of the first 30 be then? What would you have to add there? You'd need to know the first 29 in order to get to the 30th one, right? But you're close. I mean, your minds are working. I don't think I've ever seen anyone point that one out. So this one you would add 12, right? Be 42. So the rule, the formula, we're going to be doing something to these numbers. That something, that operation is usually adding, subtracting, multiplying, or dividing. But we're already adding, and we realize how tedious that's going to be, right? If we have to get all the way to 30. But is there a shortcut using any of the other operations? Do you see one yet? I'm going to go to the next screen, but I'm just going to add to this chart.
Do something with multiplication.
Say it again.
Can you do something with multiplication?
Yeah, you can. So do something with multiplication. Fifth term, something with multiplication to get 30. What would that something be? Be 6, right? Multiply by the number after. Would that work? So to get to 6 to 42, I'd have to multiply by the 7, right? So what would the sum of the first 7 even numbers be? 56. The first 8 even numbers. 72, that would be 8 times 9. Yeah, and so on and so forth. I don't need to do all this down to 30. I don't need to do all this down to 30. I now have a conjecture. You're taking that term and multiplying it by the next term to get the sum of the nth term. So when I say nth term, it's an arbitrary number. It could be 30, it could be 90, it could be 1,000. Okay? It's whatever number we want. We're going to use that variable, that arbitrary replacement there, to come up with a conjecture. So you're saying it's the nth term times the next term. So in this case, it would be the nth term times n plus 1. So to find the 30th term, it would be 30 times 31. That would answer part A. Part B then is the formula. What is the conjecture? It would be n times what?
30.
It's the current term times the next, right? Gives you that current sum. So the current term times the next would give you that current sum. So that it'd be n times n plus 1 would be your conjecture. And that's how we come up with formulas, guys. We see a pattern, we test it out, we make sure it works, and then we can prove it using some mathematical proofs, or we just try to search out a counterexample, and a lot of times you don't have to search too much to realize you're not going to find one. So that's kind of what happens here. You're not going to find one. So our assignment, so that's it, blank sheet of paper, page 93, 2 through 40 even, 47 to 53 all. What we're doing is we're just trying to find a pattern with this. So it's actually a lot easier than the example. The example is about as hard as it gets. But that wasn't terribly hard. Exercises your brain a little bit. So here's our assignment, page 93, 2 through 40 even, 47 to 53 all. We'll go ahead and we'll get out a blank sheet of paper, write that down before I put the book on the board. All right, here's the book. And again, we're just trying to find patterns to the sequence. What are the next two terms in each sequence? So looking at number 2, try to figure out what's going on. How does it change from each term?
Moves over one. Each color moves over one.
Okay, each color moves over one, so like the green's going to move over one, yep. And then from here it moves down one, right? So it's almost like it's rotating if you're just looking at one color. So over, down, over, up, over, down, over, up. It's just rotating in a clockwise manner. So to do these, you don't have to color them in, right? But so what would the first square be?
Green, purple, red, blue.
Good, yeah. So the next one, this would move up. So that one would be green. We'll put a G for green. And then purple would move over, so it'd be purple. Red would move down. And blue would move over. And then rotate that again. Green would move over, purple would move down, red would move over, blue would move up. It would rotate. Number 4, how does the word counterclockwise help you understand the word counterexample? Any ideas? Counterclockwise. You've at least heard that, right? What does it mean? Opposite, right? Against what the clock normally goes, right? So the word counter means against. So a counter example, I use the basketball example, right? You're pointing out an example and you're like, well, that's the opposite of what you're just saying, right? That tall guy is not good at basketball. That short person is good at basketball. Okay, so how does that help you understand? Well, counter means against. You guys said opposite, which is fine. It goes the opposite way, so a counter example would be a example that is opposite of the conjecture. It goes against your rule. All right, any questions or repeats before we move on? Number 6, you're finding the pattern and then use the pattern to show the next two terms. All right, first term is 1, second term is 4, and it goes to 9, and it goes to 16, 25. So what will the sixth term be? Jade?
35. Wait, no.
Close.
36.
Yeah, 36. How'd you get that?
It's going up by like odd numbers.
Yeah, it's going up by odd numbers. 3, and then 5, and then 7, and then 9, and then 11. So the next one would be 36. After that, it would be up 13. So the next one would be 49. I could continue that on forever. So the conjecture here, it's not really asking you to find the conjecture or to make a conjecture, but here it is. What's really happening here is that each term is being squared. So the first term is squared to get 1. The second term is squared to get 4. Third term squared is 9. 4 squared is 16. 5 squared is 25. It'd be 6 squared, 7 squared. So the conjecture there would be n squared to find that one. But the pattern is you just add by the next odd number, right? It says find a pattern for each sequence. The pattern there is add by the next odd number. Or you could go ahead and say, I think this is what I do here, you just square the term. 8 through 18, why don't you guys try those on your own? Sometimes it helps to say them out loud. So number 8, I don't know. Maybe it looks a little confusing. But when you hear it out loud, 1, -1, 2, -2, 3, -3, 4, -4, you know, it clicks a lot easier there, right? So hopefully you see that pattern. Then the pattern is you're going positive and then negative, right? Or you're listing opposite numbers in order. So that one would be -3, -3, +4. Number 10, it goes 15, 12, 9, 6. Do we have one for number 10 yet? Yeah, going down by 3, good. So 6 would, then the next term after 6 would be 3, and then 0. Number 12, 1 to 2, 2 to 6, 6 to 24, 24 to 120. It's going up pretty fast, ain't it? When it starts to go up fast like that, we call it going up exponentially. And that's a function of not addition or subtraction like 10 was. But what do you think? It's a function of multiplication, yeah. So what do we do from 1 to 2? What do we do from 2 to 6? 6 to 24? You guys see a pattern yet? Yeah. So from 1 to 2, it's times 2. And then 2 to 6 is times 3. 6 to 24 is times 4. 24 to 120 is times 5. So 120 times 6 will give me my next term. 720. Good quick math there. And then 720 times 7 will give me my second term needed. My math tells me 5,040. So they're highlighted there. They're a little jumbled. Why don't you try the next 2, the next 3 on your own? I'll jump in here. Feel free to use your resources on number 16. When I first saw those words, I didn't really know what they were. Then I Googled them. Raise your hand if you think you have 14. Brady, what do you think?
I got a nickel, 5 cents. That's what.
What's the so the next term would be? So I mean a nickel's right, but it's next 2 terms, right? So, huh? It's going down. It looks like it's going down, right? $1, $50, quarter. What would the next coin be? A dime, and then a nickel. Right, and then a penny. But we only need the next two. So dime, nickel. If you were to Google Aquarius, Pisces, Aries, Taurus, those are the zodiac symbols for like horoscopes or something. I don't know. It kind of goes. It's almost like they're like months almost, right? So no, if it was January, February, March, April, you would know what the next one is. Okay. In this case, it's the same idea. Now, not a lot of people are familiar with it, right? But if you were to Google it, you'd find it. The next term in this case is Gemini and Cancer. And those are the zodiac symbols. And then 18, it takes a half circle, and then it takes a half circle divided into two pieces, then a half circle divided into three pieces. The next one will be a half circle divided into four pieces, and then a half circle divided into five pieces. Comments before we move on? All right, let's do it then. So number 20, it says what is the shape of the 12th figure? The shape of the 12th figure. So circle, triangle, square, star, circle, triangle, square, star. Circle would be the next one, right? That's the 9th term. It wants the 12th. I heard someone say star. Paige, how'd you get star? You just do the pattern? Counted it out? Okay. 22 asks about the 40th figure. So maybe let's back up and come up with like a conjecture, a rule here, okay? So we don't have to count on our fingers and toes to get all the way to 40. Perfect, yeah. So what Paige is noticing is that every 4, right? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Every fourth one is going to be a star. So anything divisible by 4 is going to be a star. 12, is it divisible by 4? Yep. 40 divisible by 4? Yep. They're both going to be stars. Good job. And you can just say star. 24, I'll do this one with you. So make a conjecture. You don't have to do the chart like I did earlier. Just going to make a. How could we describe the sum of two odd numbers? Well, let's just add a couple odd numbers up. 1 and 3. What do they equal? All right. We usually need 2 or 3 to see a pattern. Oops. 3 plus 5. What does it equal? 8. We see a pattern yet? It's going to be even. Yeah, it's going to be even. 7 plus 1 is 8 again. Yeah, they're going to be even. 25 or 26. The product of two even numbers is going to be. So the product of two even numbers. So again, you're thinking about them where you can write them down. 2 times 4. 4 times 8. 10 times 10. Yeah, the product of two even numbers is going to be even. Any questions before we move on? We are using this chart here, this graph. Lightning travels much faster than thunder. So you see lightning before you hear thunder. If you count 5 seconds between the lightning and thunder, how far away is the storm? So how far away is the storm after 5 seconds? Let's see what we got here. After 10 seconds, it's 2 miles away. After 20 seconds, it's 4 miles away. 25 seconds, 25 seconds is 5 miles away. 35 seconds, 7 miles away. How many miles for 5 seconds? 1 mile. One thing I always find interesting is that we kind of think of thunder and lightning as two different things, right? Right? They're the same thing. Thunder is the sound that lightning makes. Lightning is what thunder looks like. Wow, blew your mind, didn't it? Yeah, when lightning strikes, it crashes, it makes a sound. That sound is thunder. When thunder sounds, it makes you see it first usually, or always. Thunder is lightning. Lightning is thunder. Okay, number 30. Find one counterexample to show each conjecture is false. So again, on counterexamples, if I walked into the room and said, every boy in here is wearing a white shirt, what would you say? You would say, nuh-uh. Rulin's not. Braden's not. Nuh-uh, right? So they would be counterexamples. That would be like the, nuh-uh, you're wrong, right? Your conjecture's wrong. Those would be counterexamples. So on number 30, it says angle 1 and angle 2 are supplementary. So one of the angles is acute. Can you think of a counterexample for this conjecture? So this is false. There's something out there, an example, where angle 1 and angle 2 are supplementary, but neither of them is acute. So acute meaning less than 90. If they're supplementary, what do they add up to equal? 180. So can you think of two angles that add up to 180 that neither are acute? Say it again. Yeah, what if you had two 90-degree angles? So that's really the only counterexample that would work. Yeah, if you had two 90-degree angles, right? If angle 1 was 90 and angle 2 was 90, they're not acute. They're right angles. Good job. 32. The sum of two numbers is greater than either number. Okay, the sum of two numbers, so any number at all, is greater than either number. So let's just start off here. 1 plus 2 equals 3. Okay. 1 is not greater. Sorry, the sum is greater than either number. So 3 is greater than 1. 3 is greater than 2. If I keep going, it almost seems like obvious, right? I mean, 5, if I add two numbers, that sum is going to be bigger. But this must be false, right? It's asking me to find a counterexample. It's got to be false. So what am I missing? Kinsey, is that what you're going to say? Yeah, so let's try some negative numbers. So instead of 1 plus 2, let's go negative 1 and negative 2. That would give me negative 3. So the question now is the sum greater than either number? Is negative 3 greater than negative 1? No, it's not. So there you go. There you go. Any questions, comments, concerns before we move on to the next page? All right, number 34, it's the same idea. Why don't you guys try 34, 36, 38, and 40 on your own? So 34, 1, 2, 5, 6. So the next two terms on 34. All right. I feel like I've heard from all of you. Paige, what'd you get for 34? 1, 2, 5, 6, 9. Yeah, 1, 2, 5, 6, 9, 10. There you go. 9, 10, and then 13, 14. So the pattern is it goes up 3, then 1, 3, then 1, 3, then 1. 36, looking at it. This is kind of a cool little thing. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 times 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 18. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 5. Alicia? Yeah, a bunch of 5s, right? How many? 9 of them. Oh my. So that would be 555,555,555. 38. Almost there. Same idea. Triangle, circle, square, triangle, circle, square, triangle. So we need to draw the next figure in the sequence. Think about color and shape. Triangle, circle, square, triangle, circle, square, triangle, circle, square. So it just wants the next one, right? Draw the next figure. So the next figure is a circle. Then it goes purple, purple, red, green, purple, purple, red, green. Sometimes it helps to say it out loud, but so it goes triangle, circle, square, triangle, circle, square, triangle, circle. Yeah. Sometimes it helps you to say it out loud, although it might seem like you're talking to yourself, but that's okay too. Last one, then the rest of my reviews, hopefully you'll be able to do those. And we're about out of time here in class. So we have a square, we have a couple indicators there. A little solid green corner, and then one dash mark in the bottom right corner. Look. Yes, it does add a dash mark. So I'm going to go ahead and draw this circle, or square. The solid corner is rotating, so there's my solid corner. Yeah, little hash marks are moving too, and they're moving and adding an extra mark. So there we go. The rest of them, 47 to 53, are review. Go ahead and do those on your own. Let me know if you have any questions.